In this presentation, we are going to look at the negative binomial distribution, a discrete distribution that's very similar to, let's say, the geometric distribution and the binomial distribution. We'll continue on anyway. So an oil company conducts a geological survey that indicates that an exploratory oil well should have a 20% chance of striking oil. What is the probability that the first strike comes on the third well drilled? Okay, if you're looking at that and thinking about, is this the geometric distribution? That's correct. We'll come to that shortly. The geometric distribution could be a special case of the negative binomial distribution. And that's sort of the point of what we're going with these exercises. What is the probability that the third strike comes on the seventh well drilled? Okay, very standard conventional question about the probability mass function, and then also calculate the mean and the variance. That must be what is the mean and the variance of the number of wells that must be drilled if the company wants to set up 3 producing wells. Okay, now the negative binomial distribution, just like the geometrical distribution and so on, has different ways of phrasing the question, and it's really important to get this right. In this first case here, x is the number of failures given or successes, which is not exactly what we're being asked. So down below, what we have here is x is the number of trials given or successes, and that seems to be closer to the questions that we're going to be asked here. Okay, we're told the number of successes and the number of trials that those successes took place in. Okay, so essentially what we're going to do is we're going to use this second formulation here. Okay, now, so what is the probability that the first strike comes on the third well drilled? Well, to find this, what we need to find is the probability of x equal to 3. Okay, and so this is technically a geometric random variable since we're only looking for one success, and you probably might sort of spot that when and think about it when you think about this question. So the thing about this is that the geometric random variable is a special case of the binomial random variable. So we're going to continue on as if it is a binomial random variable, and we'll just demonstrate how it sort of reduces to a geometric random variable. So we're told that p is equal to 0.20 and 1 minus p is 0.80. R is the number the number of successes. Okay, so we're looking at the first success in 3 trials. Okay, so this is what the calculation would look like. Probability of x equal 3, where we have 3 minus 1. From 3 minus 1, choose 1 minus 1, and that just reduces to 1. Okay, 0 factorial below, and so on. 2 factorial above, 2 factorial below, times 0 factorial. That just basically cancels out to 1. So, sorry, just going to go back here a second. R successes, so we look for the first successes, and x is the number of trials. So it just reverses the usual roles of x and r here with regard to the geometric distribution, but ultimately it's the same thing. Okay, so we're left with this. Probability of x equal to 3 equals 1 minus p to the power of 3 minus 1 times p to the minus 1. Okay, so we have 1 minus p squared times p, which is 0.80 squared times 0.2, which is 0.128. Actually, before I continue, I'm talking about the geometric distribution here, but just recall that there are 2 types of the geometric distribution. In this case, I think this is type 1, but there's actually, just like the negative binomial distribution, there are multiple ways of stating the problem with the geometric distribution, so you have to think of that. Now, it's a little bit outside the scope of what we're doing here, but just to sort of recall that, just like there's multiple sort of ways of phrasing the question for the negative binomial, the same thing applies to the geometric. But we'll persevere, we'll just continue on as we are. So it's around 13%, 12.8%. Okay. Second question, what is the probability that the third strike comes on the 7th well? So here what we need is a probability of x equal to 7, and in this case the number of successes is r equals 3. So we were looking for, given that there was 7 trials, what was the probability of there being 3 successes? Working in reverse, given that we had 3 successes, how long did it take to find out get those 3 successes, and what was the probability that it took 7 trials to get those 3 successes? Okay, so the probability of x equal to 7 is 7 minus 1. From 7 minus 1, choose 3 minus 1. So just using the binomial coefficients here. This is just a standard binomial coefficient calculation here. So that's from 6, choose 2. 1 minus p to the power 7 minus 3 times p cubed. 6 choose 2 is 6 by 5 divided by 2 by 1 is 15. Okay. 15 times 0.80 to the power 4 times 0.20 cubed. Working that out, you should get 5% approximately, 0.049. Okay, so there's about a 5% chance that the third strike comes on the 7th well drilled. Now, what is the mean and variance of the number of wells that must be drilled if an oil company wants to set up 3 producing wells? So essentially, the mean and the variances in this case is just actually calculate the mean and the variance of x. R and P are the two parameters there, and so 3 divided by 0.2, sorry, the expected value of x in this case is R divided by P. Okay, and that means 3 divided by 0.20, which means 15, and the variance of this is R times 1 minus P divided by P cubed. 3 times 0.80 divided by 0.20 squared, which is 60. Okay, this is essentially just standard results that correspond to this the second formulation of the negative binomial. Okay, it's just the mean given this PMF. All right.